Okay, next up is going to be Tobias, who will be showing us how to do spatial audio in Cables.gl. So let's head over there. Hello, Tobias.
Hello. Yeah, thanks for asking about spatial audio and for inviting. And the first thing what I want to mention is a little disclaimer because it needs a proper stereo audio, like 2-channel audio streaming and connection and reception on both sides, and that's not working. In the Discord app I'm using, I can only send mono because I can't install the plugin necessary on Mac, blah, blah, blah. So the patch is public, will be shared, and that's a common issue I encounter many times working with proper spatial audio in streams and especially in the browser. So sometimes Bluetooth headphones merge signals to mono, so you don't know if people receive a proper stereo signal. And I stopped ranting about this. So we don't hear perfect spatial audio now in the stream. That's a bit sad, but it's not a problem because we'll focus on what you can do with it, what it is actually compared to standard audio to give room to questions, and you can explore the patch on your own. And the most important thing is then use your own sound files, use your own assets, what you like to use with and explore, and yeah, see how it sounds. So this is a very, very simple patch. It's only a little blob helping to visualize where our audio object is situated in space, and it's sitting in the origin with some grid and some weird skybox generated background for not having a black screen. So this is my first attempt on doing something in JavaScript. So this was my project to say, hey, I finally want to learn JavaScript and use Cable as a background. And there were many audio ops already there, like, the audio buffer to store a file and play it back. And in web audio, there is the standard audio panel you see here or in the mixer. And you can pan it from left to right, like on the headphones from your left to your right ear, on the speakers, left, right side. This is called stereo in 2 channels. But there's also the panner node. It's a standard web audio object, which allows panning in 3D space and really pointing audio like a torchlight into a space, and imagine it like a beam of sound, and also have the sound objects moving around and render in a more sophisticated, more detailed way. And that's what we're looking in. So I made 2 ops because the web audio panner node always consists of 2 important parts. The first part is the so-called listener. It's basically a camera for audio, and you only need it once. And my first attempt was let's go edit it here, to get it some position. So where is our listener situated in space? And that's of course stupid because you don't want to adjust where is your listener all the time. And so I learned that in Cables there's a view matrix, for example, and that I can grab actually already existing positions, like where am I looking at? So I implemented this web audio node in a Cables way. So we have a camera, and what I do, or what the op does, you just grab the view matrix, what you're looking at, and exactly this is a spot where are you now listening at. So our listening position is always exactly the same position as the camera. And that makes it super useful and easy to use, because if you, for example, use a transform view, now we are on this track, you can use it to navigate the transform the view matrix, and the sound will appropriate follow this position. Or when I use the orbit control, I can just use orbit control, and everything I do with the spatial audio will follow this position changes. You see that the values change. I output them for if you need them. So you see the listener position changes accordingly to the update of the camera position. So everything you can do in Cables, for example, the game controller, you can use it in the same way with audio. So this is super handy for doing game-like things or wherever you use these kind of controls. And you can also use look at camera. That's quite nice because then you can animate, of course, you know this, some kind of view path and listen to the whole audio sphere at the same time. So I go back to the orbit control as a standard for this demo and for the presentation, and just go back into patch whenever you want and play around with that. So this listener you only need once. That's the most important thing, and you put it wherever you want, under a camera or a transform view or whatever. And this is the position where I listen to everything which is following now. Then, of course, we need an audio source, and that's a standard audio buffer and a standard audio player. And maybe again, you can also apply effects. It's just regular web audio objects. And then you feed them into the next op in the set, which is then called the audio object. And audio object is a standard term in spatial audio. This is like an object, like a rendered object. It's a positional audio. So the blob we are seeing here, this little green planet, is the source, the origin of audio. And from this point, you define here the audio spreads in a certain way into the world. And for example, if I move away from this blob, I also increase my distance, so it will be more quiet or more loud. And of course, you can have several of these audio objects. If you want a new audio object, you just copy paste this whole thingy, put it on the side, and then you have two audio objects and a third and a fourth. This is how you compose the whole scene. And to keep it a bit more simple for this little demo, we just leave one audio object here. It's more clear to follow then. And the nice thing now is that you feed it the audio signal, but you can use any regular transform or whatever transform operation from Cables to move the source now in space. And that's the only thing where you have to make a decision. Do you move audio objects into a fixed listener position? Or do you use the camera and move the listener position, but keep the audio objects stable? Or you use assign anim or whatever, and of course move both. And this is working nice. And then you can compose whatever you want. So you can have moving audio objects in the world. You can have rotating audio objects in the world. And at the same time, one moving listener. And this is composing a whole scene, like composing many rendered objects in a space. And because this normally is how audio looks like, so you don't see anything, and you have no reference at all what is happening. This is a little, maybe it needs some rework, a subpatch which just creates the sphere we are seeing here to visualize the settings of the audio node. So we see where is the audio located, where is it pointing to, and all the other values I will explain in a second. And you can give it a name, and yeah, so all the standard things, I think they are self-explanatory. I turn on audio now, and then we see this little friend playing. I make it a little bit more quiet. And when I'm moving away, it's getting more and more quiet until it disappears. If I move left and right, it starts to pan from the left and right side. And that's the thing you probably don't hear now. That's why I stopped the audio now. And please just explore it on your own afterwards. So I will go now into depth, into detail, what all the values of this panner node mean. And please feel free to ask questions, because that's what I like working with these audio features. And I hope I can try to explain clearly what they do.
I would be interested, like, does this need a special output device? So you're using the normal Cables output op, but does it have to be connected to some, I don't know, 5.1 sound card or something?
Yeah, very good question. I will answer that when we reach this panner mode, because this defines the output and how the output is rendered.
Okay, cool.
And then we come exactly back to this. And as you see, obviously, you don't need anything special. It's a standard web audio object, which is then pointing to the mixer and the other ones, or whatever you pick it up with. And it's in the end, we listen to a standard stereo output like 2 speakers or headphones. So that's first, so you don't need anything special. And you can't do anything more fancy than stereo with it. That's the limitation. But exactly, I go in depth with explaining those 2 functions. So this object, this operator, as I said, implements the standard web audio panner node. So I put in here some links to the Mozilla Dev where they are explained if you're interested in reading what it means. And the first thing what you define is the inner and the outer cones and their angles. And this means this is the torch beam, so to say, where the audio is projecting to. Default is 360 degree. And if I make it smaller, you see that the green circle is, no, it's disappearing. Yeah, the green circle is getting smaller and smaller. And the outer angle is the yellow ring. And what this means is that audio is actually projecting where this green beam is pointing to. That's the direction where it is heading towards. So it's pointing to me as the listener and viewer. And the green one, this is the cone and angle of, let's make it 45 degrees, quite narrow. This is the angle where the audio has its maximum volume. So if I make it 45, 45, and 0, I have a beam of audio which is only projecting very narrow in this 45 degrees. So if I turn on audio, we don't hear anything because I'm not in the beam. And I have to move into the beam to get the audio. And you hear it's a big disrupt. It's just an on-off switch. So audio, no audio.
Okay, that's pretty
So
cool. Now I get the panel node. This I really actually thought it was just an orb in the middle that will move around, but it's like super impressive. Nice.
Thanks, and it's getting better. And I hope that this is the thing I can share today, because I always miss that people use this feature because it's super simple and it makes such a beautiful, more beautiful sound. So the outer angle now gives a possibility to smooth out the whole thing. So this means we have a quiet area. You see, now I can fade in. And from the outer angle to the inner, I have some kind of fade. So now I'm at the side, I don't hear anything. But as soon as I start to rotate into the field, I fade in from touching the outer cone. There we go. And reaching the maximum volume here and going back. And this gives super smooth transitions, and I can make it bigger, of course. So I have situations like this. I can hear it a little bit from the side and then go full volume, and that's it. And the cone outer gain is the blue circle. It's appearing here. And this just means how loud is the audio even outside of this outer gain. So there you can define like a minimum level which is always present. This is helpful if you have some kind of, you want to leave some background noise, some ambient level, whatever, so it never gets 0. This just helps you to adjust it, and it affects the whole globe. So if I put this up to 1, I have maximum volume wherever I am. And these are the 3 levels that helps you to compose. Let's go back there. Let's compose where your audio is beaming at. And then you get to imagine the picture. If you start rotating this sphere now, I have like a light tower of sound beaming its laser sound torch through space, or I have characters moving through different objects. I have to move through the beams. And of course, I can then use whatever object disable this visualizer, and then I have the torus singing to me only if I look through it. And then, of course, it's up to your imagination what you start doing with this.
But of course, then all of these can be animated as well, right?
Of
so
course,
I can actually have
like
rotating audio and everything.
Yes, and of course you can also animate these values, like the cones and the angles. You can blow them up and make them tiny, whatever you want.
Awesome.
So this is beautiful and a nice feature which adds on to standard working with audio. And it's even worth just if you have one source, point it there. If you want to have an ambient, just make a 360, the default, and you hear it everywhere. So this is the volume and the panel note, the cone, like where you beam the audio. Now we come back to your question. How do we listen to this? The object itself takes in an audio file, an audio object, which can be mono or stereo, like 1 or 2 channels. Cables is standard, is always 2 channels. But it is actually a 1-channel source. It's really a point audio. It's not a stereo file. So you don't, by default, hear something like left and right. So you really hear a mono signal, a sum at a point. But you hear a perfectly spatialized rendering where it is in space and how it is moving in space. And this is like with 2 options. The default one is called equal power panning, and it's only panning left and right, like a standard left and right speaker setup or standard headphone setup, and distance. So with equal power, I don't have up and down, and I don't have like corners, but I have left and right and back and forth and all the volumes concerning this. And you can listen to this on 2 speakers, on 2 headphones, a pair of headphones, equally. The second mode, which sounds a little bit different because it's technically something completely different, is the so-called head-related transfer function panning or binaural audio panning. And these terms refer to actually it is rendered as if you listen to with 2 human ears. Head-related transfer function is a way to convolve an audio signal, recalculate it so it is you get a simulation as if you would listen with a pair of ears and a head between these ears, which does some scattering of the sound and some dampening. So binaural audio means listening to the signal as if you have 2 ears. And this, by default, only works with headphones, because only when you then this recalculated sound played back directly onto the ears, you only get true impression. And you can play back on speakers and you hear some result, but it's never, you never hear the whole sphere, you never hear 3D audio, and you never hear the space, because you need the speakers directly on your ears, like with headphones, to make it work. And this is not ambisonics, this is not Dolby Atmos, this is not Ambio or whatever is other standards. It's just spatial audio. It means render a signal in a simulation that makes a space somehow audible. And when you explore this in the patch on your own, then you really hear properly, now I'm moving up, I'm moving down, I'm moving from down left to up right. And you even hear like your back, so you can circle around the listener, hear the object moving from the front to the right, passing your back, coming left and coming back in the front. So you know how to do it. Just animate this blob, the transform, let it circle around the listener, or let the listener circle around the object, turn head related on, and there you go. So this means you need to listen to headphones to get a full expression, but this also means, yes, then we have true spatial audio. And the big bummer by this is the standard web audio implementation has quite a poor quality. So you lose some strength in the bass, you lose some impulse, like on kick drums or on short bass notes, you lose a bit of pressure, and you lose a little bit of clarity in the high frequencies, which is quite audible in the standard web audio implementation, and there's nothing you can do about it. It's because the filter templates which are baked into this web audio panel node, you can't change, you can't override, to my knowledge, and I spoke with plenty of people about it. But if you use it in production, like with audio software, then of course you by default use better filters, you use better calculations for this. But the web implementation is quite good. It's quite convincing and it's very efficient. So it's very useful. So these are the most important switches, and hopefully I could explain it well, and feel free to explore it on your own with headphones and how this is different then. Then we come to the last thing, and this is referring to this green beam we see pointing out, because we need to know how big is our whole auditory scene. So how loud is the object according to what distance. And these numbers here are just numbers. They're not normalized, they're not meters, they're not nothing, they're just numbers. And they mean a little bit different according to what panning or distance model you choose. Inverse means it's the most natural algorithm, the most natural calculation. Exponential is exponential, so it's exponential calculation of the distance, and linear model is just linear, so you go from 0 to whatever in a linear fashion. And the reference distance 5 means this is the distance from the origin of the blob to your listener where the audio volume never changes. So a reference distance of 5 means within a distance of 0 to 5 from the object, you don't hear the source getting quieter by moving away. So this is the radius you define of the standard volume, the maximum volume, which doesn't change even if you move inside or within that field. That helps a lot with game situations where you have a, for example, conversation with a character, or you have some speech. You want the character to approach, but you don't want the character to force being as close as possible to the object to have the proper volume. So you can define some safety margin or some whatever margin. So the default is around 5, and it helps you staying a little bit far from the object but have the full volume. Then the maximum distance, obviously, also to 5, but let's make it to 1. Then you see the green one is disappearing. This is where the audio stops being audible. So this was a lie because I'm in the wrong mode. I have to go to linear mode. Now I go into the front. I would have to. We're still in the reference distance, sorry. So we are too close to this 5. There we go. Get it? So I can define how far is the audio projecting into the world. This by default can be very long. So let's put it back to 10K, which is basically infinity somehow. And the roll-off factor means how fast the maximum volume goes quiet by moving away. So if I move away from this one, you see it's quite not doing a lot. So I have to increase the roll-off factor to, let's go to 20 something, go to this natural mode again, and now I can fade in. And there we go. Maybe this was too much. Let's do this one again. Or let's make it 10. That is too strong for the demo. 3. So we have the volume. And now we are fading out very fast. If I decrease the roll-off factor, of course, it gets louder. Again. Like this. Because now we are getting less quiet by moving away. I hope I could express it clearly. So reference distance means this is a circle around the object where the volume is maximum. Roll-off factor is a number that says how fast goes the sound object quiet by moving away. And the maximum distance is the distance where the audio stops being audible at all. And a little quirky thing, inverse and exponential never can go to 0, never can go fully quiet, then just can go very quiet, so you think you don't hear it, but basically it's always there. Only in linear mode can go to really full true 0 and true turned off, switched off audio. So, and I put some warnings there. So the distance must be, I think I put a 0 too much. Yes, 10K is the maximum Pananote can handle. Yeah, that's it. So basically, I would encourage you to explore some spatial audio, and I made a little web audio player for some just a web audio player for some music related stuff where I just implemented one of these blob you can move by orbit control as a simple panner. So this you can visit to explore the patch and then just exchange the audio file, put a copy paste, put another one, and go for it. So this I think it would be from my side. If you have
Super
questions,
interesting.
happy
Also
to hear.
super, like lots of stuff to play around with. It seems I really didn't think. First of all, I didn't get the visualization, so that really helps a lot. To see this beams and spheres and circles influencing the sound, and also the you said before that like stereo or the spatial audio gets bad with not having proper headsets and maybe even over the streamer, but with the distance, it worked pretty well for a presentation, I think.
Yeah, hopefully. And this is that's the most valuable thing, I would say, because I put in the patch the standard panner mode. These are the two objects available in web audio. The standard panner mode, panner, uses a so-called equal power. No, sorry, it's the linear panning or whatever. And this pans really the audio signal from 0 to 1, from left to right. So if you use the panner and pan to left, you just hear nothing on your right ear, full audio on your left ear, and vice versa. And this mode, this panner node by default uses this equal power panning, which is a way more natural behavior, calculation closer to the natural behavior of sound waves in air. So it sounds really like sound objects in the world, in the physical world, move. So you never have a full left-right swap. So you always have something left on the right side if you pan to the left, as it would occur in the natural world, because your right ear still keeps listening. And your left ear also still keeps listening if you have two unimpaired ears. And this sounds way more smooth and gives you way more less distracted sense of keeping audio perception-wise. So you accept it more as given. It's like a beautiful lighted or beautiful material. It's more natural or sound-wise.
Yeah, really big world to explore, I guess.
Yeah, do it.
Yeah.
It's fun.
Yeah, really interesting. I'm also interested in if I would develop a VR web VR website with cables, and then how would I go and so in 3D I have some idea about the units and is this meters or whatever, and you said those units are just I don't know. You basically scale it up or scale it down. How would you do that? Would you say, okay, we're in a big hall, so I just pump up the values, or we're in a small room, so I make them really small, or how would you do this?
Yes, the numbers have no reference at all. What I do, that's why I do the screen beam. For example, your explanation with the small room. So let's say where I'm standing now, I'm facing with my back the wall of the room, so that the room ends, and basically there, or this is the distance you want. Then you need to use linear mode, and then you just adjust the visualization touching the wall, and then it stops here, the audio, and that's it. That's how you can adjust it. And then, of course, this is pointing here. If you now turn this to 360 back, you have basically a whole sphere with this radius around the origin where the sound is visible. It's not a box, it's a sphere. If you really want to fill a box, you need something like Omnitone library or what is another name?
I don't
library
even
does it.
Yeah. I mean, the question, I get it with the small room, but the question is more about if I'm walking away 5 meters, how would this scale to those values?
Yes. You have to listen with your ears. There's nothing you can do with numbers. It's really and you would do inverse mode or exponential for a more natural approach. Linear is really a technical approach. Inverse mode sounds true or more believable. And then you have to adjust especially the roll-off factor, how much it's getting quieter by moving away. Then you get a sense of, do you believe what you see, what you experience, or do you not believe it audible-wise? And then you stop tweaking the numbers. That's how you basically work with spatial audio.
Yeah, okay. But it's probably like you can really be convinced easily that it's working, right? I mean, probably if you're in a big hall, you want this echo. This is probably more. You wouldn't trust the audio if there wasn't an echo in a big hall or something. But yeah, it's really interesting.
Yeah, that's the best point, because we don't hear the space now. That's true. We only hear the source of the audio. And a very nice approach is already available in Cable. It's the convolver. It's an option to make reverb, basically. And what you can do is, or what a standard trick, so to say, is you add a convolver at the end to your sum or to an audio object, and you get the direct signal from the object, and then turn up the convolver for some reverb, let's say a little bit of wet signal, and put in a standard of a church ambient, which is very easy to notice. As an example. And then this one calculates basically the whole reflections in the sphere you are in. And those actually don't need to be panned. Yeah, ideally, they should, like you move your head. But if you keep it slow and keep it for a believable room experience, it's very convincing and very well working within that framework. So this one would create the sound of a cathedral if you're in a cathedral, or a cave if you're in a cave, or whatever you want. And
okay, so in the example, I just have to turn it up? Or?
Right, you just have to turn up the dry-wet volume. I have to make a comment there. And another option is what I put in here. If you have a binaural recording, so you can, what we simulate here, you can also capture with a microphone, like hardware-wise or physically-wise. It's called a dummy head recording, or artificial head recording, or binaural recording. So basically you have a microphone which looks like a human head or close to it, and then it captures the sound as if your head is listening to it. And there I just put in a recording it's a field recording with a lot of birds flying in the city of Bochum. And if you turn on this one, you hear a very convincing spatial representation, as if you're standing in the street and the birds are chirping all over the place. And if you combine these kind of sources, you can compose super convincing spatial audio scenes within Cables with no further addition and no further processing power needed to compute more, like to compute the space, compute all the reflections, because this is really compute intensive if you have the source, and then compute all the true reflections referring in recording, in taking account your position and so on, the listener and object positions.
Yeah, it's super interesting. I think it would be very awesome, because I'm really a dummy with all those words and stuff. I have no idea about this. Would be great if you also have a toggle for those kinds of things to explore, because I would really learn experiment with it. So by turning it on, you mean just the gain from the binaural thing on the right?
Yes, true. Oh, of course, I will do this. As I will do.
Yeah,
I can update this patch a bit and make some more comments. That's where basically my reminders for not forgetting to talk about it. So tomorrow the patch will have some more comments and to explore these concepts, or I make a video on this exploring, and then you can also listen it with true stereo. It's called true stereo audio, to explore what I did just blah blah today.
Yeah.
I also have a question. First
Sure,
of all,
please.
really cool. Really want to play with this. But you said that this was computationally intensive, or did you mean that this was not computationally intensive? What's the limit of, for example, objects that we can have in space at the same time, or is there no limit?
There is limits. Not you hear dropouts. So you start adding an object, And when you see what you do is you have to calculate. And if somebody has a better way to do it, I mean, that's my first JavaScript approach before ChatGPT help, if it's help at all. And I learned a lot, and I tried to optimize it so we only calculate what is really changing. So if the position is changing, we change only the, especially in the listener, sorry. We change only here the position. If we change the rotation or how the listener is positioned in space, like pointing upward or forward, we just change these values. So this helps to reduce the computational power. And what is very expensive is calculating every sample. It's like 44,000 times a second. At every draw call, you have to recalculate where is the audio positioned and how is it rendered. And with my machine, after 6 to 8 moved object and also a moving listener, I start that some samples are missing. Then you hear like a dropout or a little hiccup or a little glitch in the output. And then you know you reach a limit.
But so it's basically 6 to 8, and then if you have to prioritize moving the objects and not the listeners to
right. And the most cost expensive thing is moving the objects, because it means recalculating per draw call, per audio time point. And you have to be careful because it always depends on the user in the end. So if you put it on mobile, for example, it works perfectly well. But some smartphones, of course, are a bit less powerful, so you have to test a little bit. And it's also very funny. You can combine it with post tracking, of course, with the webcam op and the face position, get a position, bound the listener to head tracking, so you can have a live reactive thingy. That's all possible. Mustn't be a sign anim or so. Yeah. And you can really make super stupid things which are beautiful, I would say. For example, you can just flip it around and put the listener somewhere with a view matrix. And then, for example, let the camera bound it to the position of the audio object. So basically where you listen is where the object is. So you can flip the role of the listener. So you hope you get it. So you can make some nice mirror sounding experiences, which can be stupid, but can also be very nice. You can make some very surreal experiences audio-wise if you really mirror the whole experience of where you are listening. Or you can point the character like upside down, like a little bed hanging on the ceiling, and then you listen basically everything upside down. The default is a human standing on its feet, looking forward. Yeah, that's it.
Yeah, great stuff. Thanks for showing us all of this. Also, pretty nice to see someone actually using the presentation mode in Cables with the mouse click and left click. Very good. Thank you.
Yeah, thank you very much. Very impressive. Cool. And if someone is searching for those operators, you created a team, Spatial Audio, I guess.
Right. Thanks for mentioning it. Yes. It's Spatial Audio or 3D Audio. I can't remember. You find it when you type audio, see the 3D Spatial Audio team, and then you get two yeah.
Yeah, and if you want to use those operators, then you can just join the public team, and then you can use them in your own patches. And yeah, I guess feedback is always welcome. But yeah, on the team patch you can find the user account of Tobias, and yeah, you can work with it and contact and talk about it.
Yeah, please always get in touch. I'm still learning a lot, so I'm happy about every feedback. And if you find something to improve or something else to implement, and yeah, I'm keeping up with audio in the future, so I hope I can contribute some more things.
Awesome. Thanks again. If there's no more questions, I guess we will shuffle around a bit here and then move to the boiler room to show what we've got up our sleeves for the next releases.
Cool. Great. Yep. Thank you very much.